Hi everyone, we're going to look at different kinds of correlation here in this video. So the first one, we've got average temperature versus a monthly heating bill. And as you can tell here, as the temperature goes up, the heating bill is going down. So because this line is going down from left to right, this is a negative correlation. On the right, very similarly, as the weekly exercise hours goes up, the chances of a heart attack goes down as well from left to right. So again, that means the correlation is negative. But you can tell these two are very different from each other. On the left side here, this is very close to a line. It's very close to a line of best fit if you were to draw one in. It's a little low. Let's try this. So we call this a strong negative because it's a strong linear relationship. It's not quite perfect, but it's strong, and it's going down. So strong negative. Our correlation coefficient estimate for this would be closest to -1. So R would be about -1. Not exactly -1 because the line is not perfectly linear, but it is closest to -1. For this one, it's still going down, but as you can see, the dots would be very far away from a line of best fit. So we're going to call this weak negative. And we're going to estimate our R value to be closest to -0.5. For the next one, we've got a correlation between the shoe size and exam grade, which as you can kind of tell here, it's not really going up or going down. So because of that, it's not positive or negative. We're going to call this no correlation. There doesn't seem to be a correlation between shoe size and exam grade, which kind of makes sense. So for our R estimate, it'll be closest to 0. For the next two here, these are both increasing. So they're going to be positive correlations because from left to right, it is going up on this one and on this one. They're both increasing, so they're both going to be positive correlations. But again, the one on the left is a lot stronger than the one on the right would be if you were to draw on the lines of best fit. You can see that. So we're going to call this strong positive, and R value closest to 1. And on the one on the right, this would be weak positive, and an R value that's closest to 0.5. That's how we estimate R values using the different correlations here. Again, strong means it's closest to 1 if it's positive, or it means it's closest to -1 if it's negative. And then for weak, it'll be closer to -0.5 if it's going down, or 0.5 if it's going up.